based on what we've been doing for the last while with our clients. Actually, it's over a year now, probably more than a year, that we've been trying to do this kind of thing. And a lot of the clients that I work with, the CIOs and the senior people who do all the AI, or not the AI, the automations and so on, are saying, we don't get it. And all this hype, where's the beef? We're spending a fortune on tokens and people are individually getting benefit from it. But in terms of our business and our bottom line and profits, we just don't see it. And there's a worry that it's not sustainable, that if these big tech companies are spending billions and not actually making profits, is it all going to be a bubble that'll burst? And I'm saying, no, 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 relax. Here's where the beef is, right? You have your no-code automations up and running, and you're automating everything, and you're getting huge financial benefits from that. You've all this artificial intelligence technology, and it's all getting better so fast, and it's brilliant. Most of it is stuff that isn't useful for automating businesses. But, so you have assistants and you have co-pilots and all this touchy-feely stuff. But in the middle here is the thing that's going to make a difference in 2025, and then that is agents. And that's where we're able to improve our automations by adding in just a little bit of intelligence in here. And I think this is where the billions, the billions of billions are going to come from an economic point of view. And it's certainly where I think people should be putting their skills. Because if you're one of the people who are able to do no-code automations of business processes and use agents to add AI to those, then I think there's going to be a big demand. And I certainly understand that that's why a big investment is being made by Coda in Coda Brain. And I'm hoping that Coda Brain is going to improve this, but not really change it very much from what I've been doing. So the question is, how do we build agents in Coda, and how do we stop them hallucinating? Because that's the big barrier that stops people from trusting what they're producing. And some of my clients are financial services, and it's got to be 100% right every time, or they just can't use it.
Yep.
And one of the examples that I'm going to give here, just briefly, just to set the stage, is here's a Coda automation that's being used by a company that produces these big, complicated water pumps for mines and for quarries and building sites. And the customer fills out an order form, which is quite a complicated piece of UI using Coda. It doesn't generate an order, it generates a requirement because the customer doesn't know enough to make sure that they've gotten all these different bits and pieces all put in properly. That requirement then goes to an engineer who uses another Coda app to configure what the customer is looking for. And this engineer is an expert and has access to a lot of technical specs, the supplier catalog for all the bits and pieces and the parts. And they've developed their own procedure manuals that explain exactly how to classify the different use cases that people have and build a solution. And from that, they build a bill of materials, which is basically a list of all the parts that need to be put together to make a solution for this customer. And when that's confirmed by the customer, now you have an order, and that goes to a dispatcher in a warehouse who runs a warehouse application, who then pulls out all the bits and pieces and sticks them on a truck and sends them off to the customer. And eventually the customer will get the delivery. There's a delivery docket that says, here's all your bits. They sign off the delivery, and eventually somebody in finance delivers an invoice. This is all bog standard, happy as you go Coda automation. Could be done in any other no-code tool as well. And what this customer doesn't want, or sorry, what this particular operation don't want, is to give their customer a chatbot that says, let me help you build one of these things. They don't want that. They are happy with the customer filling out the requirements form. And they don't want to give the engineer a co-pilot that says, let me help you. Let me look at what you're doing. Okay, I see what you're doing here. Let me, Instead, they want to surgically remove this piece of the process and replace it with an agent so that this will just flow straight through as an automation. The engineer may have a supervisory role and take a check to make sure that nothing weird is going on, but basically you're looking to replace all of this with an agent. Now, the first time I was challenged with doing that. That was more than a year ago. LangChain was the way you did it. So I went into LangChain, learned how to do agents in LangChain, which is a Python-based development system. And so you use Python to do.
Interrupt you just a second. One thing that I thought was worth mentioning is in the slide you had before, because Max has told me about this before, and I just wanted to make sure that's not getting lost. This entire process, the stages are automated, but the task that relates to the engineer still relies on human judgment. So the company did not automate that part at this point.
Yeah, they automated it insofar as they gave a user interface and all the formulas and buttons and doodads are in there, but you still have to have this knowledge.
And that's what you now identified to say, okay, then now let's put AI to the task that has not yet been able to automate.
Yeah. And it's an important point that we're not rebuilding everything from scratch because AI has suddenly popped up. We're saying, no, we're just going to replace this one little piece of, and that means that we get all of our existing tables, all of our existing forms and workflows, all of our formulas, all of our actions, everything stays the same. We're just going to replace this one piece here with an agent. And as I said, the first agents we used were LangChain, and that's, you have to know Python. And so we had to upload all our documents into a knowledge corpus, and that means you're building a custom GPT that does this RAG, this, the whole thing of being able to use the LLM to understand the language of the instructions, but it answers its questions using this body of knowledge. So you build a huge, big, complicated prompt. And if any of you have been involved in building prompts, you quickly get into some very, very sophisticated language. Lawyers, Doug, do very well at this because they're used to writing language with precision and with consequence, right? The rest of us, we're struggling. And you end up with prompts that have more clauses in them saying, don't do this and don't do that. Because when you test it first, it works. And then every now and then it comes up with something, it puts quotation marks, or it says, I'm happy to help you with this. Say, no, stop saying that, stop doing this, stop doing that. Now, it doesn't have any memory. These language models don't remember anything you're doing. So if it's more than one step, you need to build this object, this memory. So within LangChain, you build memory objects that remember things. You build these tools. And each tool is doing something that the LLM can't do. So this one says, here's how you go to the internet to do a search. This tool might say, here's how you use this API to get the latest data from this supplier. This one might say, here's how to use an API to update a database with the results. This is a complicated procedure that does all of the hydrostatic and hydrodynamic calculations that are needed to work it out, because the LLM can't do any of that. And then you get your output. And your output is normally a big, long, squidgy piece of text. And how do you get the input in? LangChain doesn't help you there. What do you do with the output? LangChain doesn't help you with that. So you put all of this into a pack, and that's how you get at it from Coda. We got this working, and the customer wasn't happy. They said, we don't want our citizen developers, our makers, having to learn Python and JavaScript. They already know how to build relational tables and formulas. So why can't we do this in Coda? And after I'd gone around the houses here a few times, I started to notice the pattern. And I thought, this really does map to something Coda is good at doing. Right? And so we ended up being able to replicate all of this, but in Coda, and without doing anything fancy or extra. So you still have to upload your documents. If you're going to use documents in a knowledge base, you upload those into a vector database in OpenAI, and you get yourself a custom GPT. That's fairly standard. It's quite easy to do. Now we're using Coda AI columns in a table to handle all of the AI stuff. And we're using Coda formulas to do the bits that the LLM can't do. So we have a formula for doing an API call, or you have a formula for doing your hydrostatic calculations. We have a formula that determines what to do next and which category things fit into and so on. We don't need memory because we've got everything in our Coda tables. Everything just sits in your Coda. Once you make this change, you suddenly think, this is so much easier. We use our existing Coda UI dialogues and forms for the input, and the output goes to our usual Coda action formulas that say, upload this to this database, change this the way we normally do. So the whole thing becomes an AI agent written using nothing but AI formulas. And in fact, if you're not using a vector database, you can just use Coda AI. You don't need to have a pack. But if you are using a vector database, then there's a little pack that you can use that does practically the same thing. Going to stop here for a moment and see if anybody's got lost in the dust. Or are you all keeping up with me?
No, it's good. It's
yep.
great. Yeah.
Okay. So let's have a look at these agents that we've built.
Max,
okay, sorry,
allow
go
me
ahead.
to ask a question, please.
Yep.
So where you say if we don't use an assistant, so if we don't use a pack if we don't upload our documents to, for example, an OpenAI assistant and then connect it via a pack to our Coda doc, is that in the future where we'd be querying Coda Brain directly?
That's where Coda Brain is presumably going to fit right in, is that we won't have to use a pack the Coda AI will be extended to be able to do that, right?
Understood. Wonderful.
So from here on in, I'm not going to use RAG. I'm only going to use Coda AI or OpenAI directly. The RAG thing gets complicated. I'll leave that for another day. So here's a classic example, a real one from an insurance broker where emails are coming in different languages. The email agent translates these into English if they're of the right language. We're only allowed to use certain languages for legal reasons. And then it passes them over to an instruction agent, which is another table. Every time a new record appears in here, a new row, the instruction agent looks inside the text and pulls out the instructions and creates a new instruction for each type. And then if the instruction is straightforward, it will write out the transaction to the transaction table. And this will eventually get sent up to a mainframe that implements all of the changes that the customers have asked for over here. However, some changes are not so clear and they get sent over to a special agent called a change agent, which then analyzes it and says, well, this is change of cover, this is a change of the type of the policy, this is a change of the value of the policy. And so it creates a different transaction based upon further analysis. And we're using AI because you can't write a formula that does this or this or this, right? It's beyond the ability to use a formula. So if I click on this button to run the agents, you'll see the agents running. The one that's running is highlighted. And so this one starts, it creates these, they run one after another. Every now and then you'll see the new transactions appearing over here. And every now and then one of the transactions is not simple and it goes to the change agent, which then figures out what type of change it is. And so you see the whole thing running here. And it, takes a few moments. None of this is blindingly fast. It will be in the future, especially when you start to be able to download the models into memory. So they'll sit inside your browser. And then when it's finished, all the transactions have been generated. And each one of these is just an ordinary table with AI prompts inside it. But we've orchestrated the whole thing so that it runs smoothly. And you'll see that only one agent is running at any one time. And that's because if you try and do too many AI things at once, the server will throttle you. It'll cut down, and it actually takes longer. It's much faster if you give it just one at a time. Okay. So this is what we've done. Okay, go ahead, Christian.
Yeah. So the change agent, that's Coda AI, or is that a pack of this AI?
No, this is Coda AI. There's no packs used in this. I'm just using good old Coda AI for all of this.
Well, right? that's impressive.
Now, I will talk a little bit later about the differences between Coda AI and using a pack. But for this type of stuff, ordinary Coda AI is fine. Go ahead, Nina.
The instruction agent is the one, the email agent hands off the task to the instruction agent. Yes. And the instruction agent on its own calls upon the change agent if it says, I can't figure this out, I need to bring in the change agent.
Yeah, so if we go down here, all of these are instructions that it understood. So it has classified them to say, I understand this. It's an instruction to create a new insurance policy. And so it goes over here and it says, here's the type is new, here's the number I want, and here's the amount, right? But every now and then it comes across something where somebody has said, please change the policy due to an increase in the value of my property. And it says, okay, I'm not sure what to do with that. I'll hand it to the change agent, which has different prompts and might actually be using RAG or something more sophisticated to do more work. And it then, so this ability to hand work over from one agent to another is part of how this works. And I'll show you now in a moment how that happens, right? I'm going to use a simpler demonstration when we come to looking at it. But what I'm trying to get at here is what we are now, we called it originally agentics, which is a bit of a mad word that we just made up, but now we're calling it precision AI because we have a better idea of what it is we're trying to do. We want AI to be deterministic, reliable, and accurate. And none of your squidgy, variable stuff where you put in a prompt and you really don't know you're going to get what you want out of it. Sometimes it works and sometimes it doesn't. And the way we do that is we want to use as much AI as is necessary, but only as little as possible. So if it can be done with a formula, then let's use a formula. Otherwise, and if you don't know what the formula is, you can ask AI to generate the formula, right? Nobody knows regex well enough to be able to just sit down and whack it all in. You ask AI to generate your regex to say for example, finding policy numbers where they could be this format or that format, and the hyphen could be here or it could be there, and you say, okay, give me a regex that does this, and AI will give you a regex formula and you stick it in. But you don't use AI for the stuff that it's bad at. It's bad at calculations, even simple counting, adding numbers, multiplying numbers. Use formulas for that. Don't ask AI to do that. Character manipulation is the same. It isn't able to. Procedural logic. It is possible to give a big, complicated prompt that has if, then, else's, and all the loops and branches in it, but every now and then it just gets lost. So instead, we use formulas with ifs and for eaches to handle that and only pass the small results over to the AI. Remembering things, we keep everything in our database tables. Complex prompts and complex outputs together are what cause hallucinations. When you end up with more than a few thousand tokens sloshing around in there, that's when it starts hallucination. So we find the way to stop hallucination is always ask for classifications. Here's 6 options, pick one of them that matches best. That doesn't give you as many hallucinations. Or if you're not going to use limited options, ask for formatted output. I want this as JSON, and the AI is much more likely to. But if every step with these small steps is so simple, you won't get hallucinations. Short, highly focused, very clear prompts with short, highly focused, straightforward, structured answers don't get hallucinated. It's only when you get into big, complicated stuff. So we break it down into simple steps. And for every one of those steps, we follow these 5. Use a formula to build the prompt and use your data from your tables inside the prompt. Hand it over to the AI, but make sure the prompt has a single purpose. So there's no complex logic. It's a small context and you won't get any hallucinations. Then you use a formula to parse the response, to break it down, to pull out the bits of data you want and to store those in your tables. We use action formulas overall to regulate or orchestrate how the whole thing works. And I'll show you that in a moment. And then we're asking for formatted output as often as we can because the AI does much better with formatted output. And we find it much easier to process the result if it's in a highly formatted output. So if I take a look at this, we have here, this is a simplified version of the agents we had before that are taking an input in different languages, figuring out what language it is. So here's the prompt, right? It says, what language is the text below written in? Respond with a single word. Right? I'm not saying you are an expert in European languages from the 24th century or anything like that, right? The format we use is give the instruction first and then give the data. right? And if you're giving examples, give the instruction first, then give the examples, but put the data at the end, because this is a big, long, complicated body. Don't put it in the middle here, because you'll end up with several paragraphs in the middle of a prompt. It can be a bit confusing. And the same thing then when it comes to this one is saying, translate the text below from the language you've already figured out into English verbatim. Do not add any other text. Boom. And it just works, right? And I'm not using any packs. The ordinary AI will do it. And then the instructions, I'm saying, the message below contains several instructions. Please list those instructions one per line. And the text contains instructions spread over several sentences. So I'm trying to get AI to scrunch those multiple clauses and sentences together. So when I click this button, we'll see it running, and it just goes bump, 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 right? And when it creates the instructions, they appear over here. And then it starts going through. Now I'm doing something I said not to do. I'm actually using AI to find the amounts and the dates, and that's just to give us lots of AI to test here. Normally you'd use a formula for that. So the way we do this, and the reason I do it, if we look at the button here that runs it, it says, click the AI button on the inputs, and then click all the AI buttons on the output table. And so I'm saying, do this, do this, do this. And what does that do? It's saying, refresh the assistant, first the language, then the English, then the instructions. Because if I don't do it this way, AI, or Coda, tries to run the AI simultaneously across them all, which means it sometimes tries to translate without first of all knowing what the language is. Sometimes it tries to come up with the instructions when it hasn't even finished translating. And that's where you get weird things happening. So it sometimes says, you know, the text contains no instructions, and that's because it hasn't yet been translated. So by forcing it to do it in the sequence I want, I get it in the sequence that makes sense. But also, when it tries to do all of them at once, it stalls. There's some sort of throttling that's happening at the other end. That means if you're trying to do more than one, it just says no, and it does them at random. And you'll see these things coming back in a random sequence. So I use an action formula to sequence the whole thing, and I use action formulas within each one of these to sequence what happens on each row. Now there's a bug, and I want to just briefly show you what the bug is. When you're running the refresh assistant, you can't say this row. I don't know why, but it doesn't work. You have to say the name of the table and then the column, and then it'll work. It's weird. But anyway, so this is how we figured out eventually how to do agents using nothing other than standard Coda.